Mic test, okay. So we are going to see some more problems regarding this yesterday's tension, how to find the tension in a string, okay. And see these examples. There are two pulleys. To take this example, so its mass is 2m, connected m, both are connected with the help of a string that is passed over a pulley. That pulley is fixed to the roof, okay. So this is roof, and in this case there is another case, another pulley. So there is a mass m here that is passed over the pulley. There is a force F acts on that. That force is 2mg, okay, 2mg, okay. It is moving up with acceleration a, it is moving down with an acceleration a. So here it is also moving with an acceleration a, okay, and it is moving down, okay. So the two pulley arrangements in the figure A and figure B, figure A and figure B, they are identical, okay. The mass of the rope is negligible, so mass of this rope is negligible, that is ideal conditions. And in mass m is lifted up by attaching a 2m at other end of the rope. So in the figure A, this mass m is pulled up with the help of mass 2m, okay. That is, everything is shown in the figure. In figure B, mass m is lifted up by using other end of the rope with a constant downward force. What is F here? F is a constant downward force. F is equal to 2mg in the figure B, okay. In which case acceleration of m is more. So in the figures A and B, in the figures A and B, in figure A and B, which case acceleration of m is more, which case acceleration of m is more. First option A, second option B, second option both same, fourth option none. So what is your answer? Okay. So here there are two cases. So this m is lifted up with the mass 2m. This m is lifted up by using a force 2mg. So in which case we want accelerations, we have to compare in the figure A and B. And in which case acceleration is more. That is the question. So by applying Newton's laws, okay, so we find. So in this case, you first find the acceleration. So what is the case A? So I am going to find this case A, figure A. So what is the acceleration of the system? In figure A, acceleration is net pulling force by net mass. So use this formula, net pulling force by net mass, okay. So what is net pulling force? 2mg is acting down and this mg is acting down because of gravitational force. On the system, the net force is 2mg, it is opposed by mg, okay. So that is 2mg minus mg. So its motion is opposed by this. So net pulling force is 2mg minus mg by net mass. Net mass is m plus 2m. That is, you have to take 3m. Okay, net mass is 2m plus m. I am writing separately. So what you will get? mg, 2mg minus mg by 3m. Okay, so that is m get cancelled. So acceleration in the figure is g by 3. And in the figure A, in the figure B, I want acceleration. So what is the acceleration in the figure B? So here net force is only F. So acceleration is equal to, in case B, this is, let it be A1, case A. This is case B. Okay. So I am using the same formula. What is the net pulling force here? 2mg. Okay. So 2mg by, what is the net mass here? Net mass is only m. So there is no mass at other end. Okay. So it is m get cancelled. You will get answer 2g. So in which case acceleration is more? Acceleration of B is greater than acceleration of A. So both are not equal. So in which case acceleration is more? In case B. So this is the answer. Okay. Suppose if you want tension in the string, in this case, what is the tension in the string? In the case A. Suppose if you want that one also. So how do you calculate that? Okay. I want a tension in the string. You draw FBD. So if you want tension in the string, tension on either end of the string is same, because I assumed that it is a ideal pulley and the string is inextensible, massless string. So tension in the string case A is this. So to get tension, you draw FBDs. FBD. You can draw either FBD of 2m or m. That is your wish. I am drawing the FBD of m. So m is, I consider as point mass. Tension is acting up. Its weight mg is acting downwards. Overall, it is moving up with an acceleration a. So apply Newton's second law. You will get a tension in the string. So since the resultant force is acting up, so upward force minus downward force, T minus mg is equal to ma. This is Newton's second law. So I want T, that is mg plus ma. What is a in case a? G by 3. So that is mg plus mg by 3. That is 3 plus 1, 4. 4 by 3 mg. That is the tension in this case. Suppose you want tension in the case B. So can you say tension in the case B? So the tension in the case B is equal to pulling force. That is 2 mg. Okay. So here you are pulling with your hand with a force F. So this tension is also Newton's third law. There will be, as you are pulling down with your hand, that is action, the string pulls you up with the same force 2 mg. That is the force in the tension. That is tension in the string. Okay. So that is T. So the tension in the string in case B is 2 mg. Take this example. Next problem. So you take next problem. So there is a pulley and its mass m, a, and its b and c in connected with the c. Okay, a, b, c. The tension in this string is T1, here it is T1, here the connected is T2. Okay. So overall it is moving down with an acceleration a. It is rising up with an acceleration a. Okay, 3 equal weights each of mass m hanging from the string as passed over a fixed pulley as shown in the figure. So the mass of m, mass of A is m, mass of B is m, mass of C is m. So these are identical mass. They are connected with the help of the 2 strings as shown in the figure with the help of this pulley. Okay, that pulley is fixed to the roof as shown in the figure. Now what are the tensions in the string connecting between? We want to find tension in the string. Find the tension in the string. Find the tension in the string connecting weights. Connecting weights A and B, A and B, and 2. Connecting between and B and C. B and C. So that is the problem. Okay. So find the tensions in the string connecting between the A and B. Let it be T1. Connecting strings between the T2. Let it be T2. B and C. Okay. So as usual we are solving the problems. The first step is first you find the acceleration of the system. Okay. So acceleration of the system. This is a pulley is fixed. So what is the acceleration of the system? Net pulling force by net mass. So step number 1. What is the acceleration of the system? A is equal to net pulling force by net mass. Okay. Net pulling force by net mass. This is the solution. So A is equal to net pulling force is C. Here mg weight is m. Here is m. M plus m 2m. This is m. So the total weight on the right side is 2m. Left side is mg. Right side is 2mg. Which is greater? 2mg right side. Left side mg. Which is greater? 2mg is greater. So ultimately the B and C blocks moves down and the block A moves up. Since these 3 are connected with the same strings, they are connected. Since they are connected bodies, the acceleration is same for all these 3. So that common acceleration is we have to get net pulling force by net mass. Net pulling force is 2mg on the right side minus left side is mg by net mass m plus m plus m, that is 3m. So that is mg by 2mg minus mg, mg by 3m. So that is g by 3. Okay, that is acceleration of the system. So what is acceleration of A, acceleration of B, acceleration of C will be equal to acceleration of the system, that is equal to g by 3. Okay, I want a tension T1. So you dot FBD. FBD of A. Okay, what is FBD of A? So see how I will drawing the FBD. A, T1 is up, T2 is mg is down because the A has mass m. So I will draw this is the FBD. So this system, this block A, when you are drawing this FBD of A, you isolate that and you study the motion of A. Okay, so this A is moving up with an acceleration A, g by 3. So you apply Newton's second law. So what is Newton's second law? Resultant force T1 minus mg. Since the block A is moving up, you have to subtract up minus down. If it is moving down, you subtract down minus up. Okay, so T1 minus mg is equal to what you will get? Ma. Okay, so what is T1? M1g mg plus ma. What is A? G by 3. So what you will get here? Tension in the string T1 is equal to 1 plus 1 by 3, 4 by 3. That is 4 by 3 mg. So I got tension in the string connecting between the points A and B. Okay. So I want tension T2. So I will draw the FBD of, so I am doing here. So I will draw FBD of C. FBD of C. You can draw B also. That is left to you. Okay. So FBD of C. So C totally it is moving down. It has weight mg. T2 is acting up on this. So here tension I represent with a double arrow. What does it mean? Newton's third law. If C2 pulls the B with the force T2, B pulls the C with the force T2. That is the meaning of this double arrow. Okay. So this C body ultimately moving down. So apply Newton's second law. Here it is moving down. So you write down minus up. So resultant force down is mg minus T2 is equal to ma. Okay. We want T2. So T2 is equal to mg minus ma. So what is A? M into A. A is g by 3. Since acceleration of C is equal to acceleration of A, that is equal to acceleration of B. So 1 minus 1 by 3, 2 by 3. 3 minus 1, 2 by 3 mg. So that is tension connecting between the strings B and C. Okay. It is given by T2 is equal to 2 by 3 mg. Take this. So next one. You take this example. A block of mass 25 kg. A block of mass 25 kg is raised by a 50 kg man. 50 kg man in two different ways. As shown in the figure. Okay. What is the action of the floor? What is the action of the floor? What is the action on the floor? What is the action on the floor? On the floor by the man. In two cases. So that is the question number 1. If the floor yields to a normal force 700 newtons, which mode should be man adopt to lift the block without further yielding. Which mode should the man adopt to lift the block without the floor yielding. So here two cases. Okay, so the first case is man is standing and he pulls a bucket 25 kgs, this weight, with the help of string. This is 25 kgs. Okay, so the man is standing here and he is pulling this rope. Okay, this is the case one. This is the stand. Let it be a floor which is at certain height. Okay, in the second case, to lift the same 25 kg, same weight, he uses a pulley system. So here man uses a pulley to pull this. Okay, it is connected fixed here. So this is, let us assume the man pulls a bucket of water from a well. Let us assume a man pulls a bucket of water from a well. He pulls the bucket directly by standing on this floor, and in the second case he uses a pulley system. Okay, this is the pulley system. Okay, this is the figure A, this is the figure B. Now the question is, now you check this one. Now you read the question and try to understand. Okay, so a block of mass 25 kg is raised by a 50 kg man. So mass of the man is, let it be 50 kg. Okay, here is also 50 kg. So this is small m, let it be 25 kg. In two different ways. This is the way one, that is way two, as shown in the figure. What is the action of the floor by the man? Action on in two cases. Action on the floor we want. So the man exerts a certain force on this floor. We want that action. The force exerted by the man on the floor, and the floor in turn exerted a force. This floor exerted a force on the man. That is, let it be M. So we want that in the two cases. For that, so the case A, so solution. So I am using here case A. So this is case A. Let it be. Okay. So this is case A. So figure A. So what you draw the FBD of man. Okay. FBD of man I am drawing. Okay. So what is FBD of man? Man has mass 50 kg and he is standing on a floor. His weight acts vertically downwards, and the floor in turn exerts a force M. Okay, up. What are the other forces acting on the man? This man pulls this bucket with a force T, let it be T. With the same force, the string pulls the man down. So with the same force, the string pulls the man down. See, listen carefully. Here I am applying Newton's third law. If man pulls this 25 kg weight with a force T, let it be, the string applies the same force on the man down. Man is pulling up, string is pulling the man down. That is reaction. So in the forces acting on the man is also acting in T, that is down. So what is N here? From this equation, N is equal to mg plus T, since the man is in equilibrium. So what is the net force acted by the man on the floor? Mg, that is 50 into G, let it be 10. What is the T? So tension in the string is, so you draw FBD of this FBD of small m. So what are the forces acting on this small m? So T up and its weight down mg. Since it is moving slowly up, pulling with a force F, this T is equal to mg. So what is mg? 25 into G, let it be 10. So that is T is equal to 250 newtons. Okay. So I will substitute, instead of T, I substitute 250 newtons. 25 into 10. So that is 250 plus 500. 500 plus 250. That is, N is 750 newtons. That means the force exerted by the man on the floor or force exerted by the floor on the man, both are same, action, reaction. So we want action on the floor. So action on the floor is force exerted by the man on the floor. This is action. If this becomes action, this will become reaction. Okay. So what is that? In case A, it is 750 newtons. But by applying this 700 newtons normal force, it yields. Okay. So by 750, this floor will yields. Okay. In this case. Now check in this case B. Okay. So what is the case B? I will draw this one. Which mode should be the man be lifted block without the floor yielding? Okay. 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 So now case B. So case A, I explained here. Case B. Now I am going to explain here. What is FBD of man? FBD of man. So M is M. Here the pulls the man pulls the string with a force T, let it be. So this string, I will extend this one because pulley is a little bit at a higher, like this. Okay. So the man pulls the string like this. So he pulls down. So it pulls up. So the man pulls the string with a force T. The string pulls the man up with a force T. So what is the FBD of M? The force acting on the man is T up, its weight mg down. The force exerted by the floor on the man is up. So that is M up. That is called normal reaction. Okay? Clear? So I will take this one as M, this one as T. Both are in the same direction. Okay? This is M, man. Okay? What are the forces acting on the man? Tension in the string, up. Force exerted by the floor on the man, up. Weight of the man, mg, down. So these are the forces acting on the man. Now you take the equations. Since it is in equilibrium, T plus N is equal to mg. So what is M? mg minus T. Okay, you call it as equation 1. Now, they draw the FBD of small m, that is block, bucket of water, let it be. So tension T, so it is small mg. Okay, so this is the tension in this string, let it be T. Okay, so it is rising up. So slowly it is rising up without acceleration. Okay, so acceleration is 0 since T is equal to mg here. T is equal to mg. What is mg? 25 into 10, that is 250 newtons. Okay, so I am substituting this T value here. So what you will get? N is equal to, so N is equal to mg, that is 50 into g, 10 minus 250. So what you will get? 500 minus 250, 250 newtons. Okay, so this is the answer for B. So in which case this force exerted, now in case B, the force exerted by the man on the floor, how much? N is equal to 250. It is less force than in the case 1. In case 1, man applies a force 750 newtons, but it yields at 700 newtons only. But here the man exerted a force on the floor is 250 newtons only, so it does not yield. Okay, so the force exerted by the floor on the man is also same. Okay, this is R, both are same. So in which case man preferable? Okay, so in which case man preferable? So here he is applying only 250 newtons. In this case he is applying 750 newtons, isn't it? So in which case he feel comforts? In the case B, he is using only 250 newtons less. So in this case, its force exerted by the man is less. So he feel comfort. Okay? Because, so by, you can see in this problem the advantage of pulleys using. Okay, clear? In this example, it is clear that by using the pulleys, the man feel comforts to pull the bucket of water from a well. Clear? Take this. Next example. There are 10 1 rupee coins. They are placed on one another. What are these? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is this? 1 rupee coin. 1 rupee coins are placed on 10 1 rupee coins are put on the top of each other as shown in the figure on a table. So this is a table. Okay, these coins are placed on the table. Each coin has mass. Mass of the coin is m. Let it be m. Okay, mass of the each coin, let it be m. Now given, find in the given diagram, find magnitude and direction. Magnitude and direction. Find magnitude and direction of A. First one, the force on the coin. Force on the coin. Coin 7 counted from bottom. So you are counted from bottom due to all the coins. Due to all the coins. All the coins on its top. On its top. B. Force on the seventh coin. Force on the seventh coin by the eighth coin. 8th coin. Next, C. Direction of the 6th coin. Reaction of the 6th coin. Reaction of the 6th coin on the 7th coin. Okay, so this is the problem. So in this problem you try to understand what is given. So there are 10 1 rupee coins, each having the mass m. Okay, they are placed on the table, one over the other. So they are placed like this as shown in the figure. Okay, now we want force on the coin 7 due to all the coins on its top. So we want force on the 7th coin due to all the coins on its top. On the top, how many coins are there? 3 coins. So the 3 coins weight fall on the 7th coin. So answer this for A. Solution. Answers. Solution. So force on the coin 7 due to all the coins on its top. So for this, what is the answer? So the entire weight is the weight of 3 coins fall on 7. So 3 coins. Each coin has weight mg. 3 coins weight has 3 mg. Okay. So this is the answer for the question A. So this is the solution for A. Solution B. The force on the 7th coin by 8th coin. See, 8th coins, 2 coins are there. 2 coins weight fall on the 8th coin. So 8th coin, it has its own weight. So these 3 coins, 1, 2, 3, again fall on this 8th coin. So the force exerted on the 7th coin due to 8th coin is also 3 mg. So the answer for B is also 3 mg, because 2 weights coins weight 9 and 10 coins weight fall on 8th coin, and it has its own weight mg. So 2 mg plus mg is 3 mg. So that is 3 mg. So the answer for the B is also 3 mg. C. The reaction of 6th coin on 7th coin. So the reactional force is the 4 coins weight acts on 6th coin. That is action. So what is the reaction of 6th coin on 7th coin? Is from Newton's third law. It is 4 mg. So reactional force. So reaction of 6th coin, reaction of 6th on the 7th coin, or the force exerted by 7th coin on 6th coin. So both are same. So this is reaction. This will becomes action. Okay. So this will become reaction. So what is the answer? It is force exerted on 7th coin by 6th coin is. It is. So 6 coins, 4 coins weight is the weight 1, 2, 3, 4. These 4 coins weight fall on the 6th coins. So answer 4 mg. Okay. So this is the answer. Take this. Okay.